Good morning. This video is over linear relationships using multiple representations. So before we do that, let's look at our number routine about constant or proportionality. Find a constant proportionality for each person. There's Bob and Kathy. Constant proportionality is just unit rate. You do not need to memorize this formula, but the formula is K equal Y over X. You will always be given this formula if you're asked this question. So let's look at Bob. In Bob is the orange line. I'm going to pick one of the points from it. I guess I'll pick this one right here. It's read as in 4 weeks, he saved $60. This point says in 2 weeks, he saves $30. So let's think, if this is unit rate, in 2 weeks he saved $30, how much did he save per week? Each week, $15. 2 is the X, this is the X-axis, and the amount saved is the Y-axis. So let's use this formula. Let's substitute the Y with 30 and substitute the X with 2. That's 15. So the constant proportionality is for Bob is 15. In other words, he saved $15 each week. In Kathy, let's use this point. She saves in 2 weeks $20 or 3 weeks $30. So 20, this is X, this is Y. So she saves $10 each week or just 10. So math happens, it's communicated. We're going to given a story, you're going to help me create a table, an equation, and a graph from it. When I visited New York City, I had to get a cab from the airport. The cab charged $5 per passenger and $2 per mile. How much will I pay to ride across town? Well, first of all, I am traveling alone. So really, am I paying more than $5 per passenger? So one passenger equal $5. Then I will have to pay $2 for every mile I drive. So from LaGuardia to Manhattan, it's many miles. It's a lot. It's not that close. I do take the subways a lot of times, but I have taken the cab. So let's think. In 0 miles, let's do our table first. Or we can start with the equation. I'm going to start with the table first. In 0 miles, how much have I paid? Well, first of all, I paid $5 for sitting in that cab. That's because this one passenger costs $5. That's a sitting fee. But I haven't gone any miles. The car hasn't moved. So will I have to pay $2 every mile? No, I will not have to. 2 times 0 plus 5 is, so it'll be $5. In 1 mile, how much will I have to pay? $2 for that first mile plus $5 sitting fee, that's $7. If the cab has gone 2 miles, I pay $2 for every mile. 2 plus 2 is 4. So that's $2 times 2 miles is $4 plus $5 sitting fee is $9. If I have to pay $2 for every mile and I've gone 3 miles, that's $6 plus 5 is 11. If I have to pay $2 for every mile and I've gone 4 miles, that's 8 plus 5 is 13. So let's look at our equation. Y is the total cab fare. So X must be the number of miles. Do you remember dependent and independent? We just barely talked about it. Which one is the dependent and which one's the independent? Which one depends on what? To find the number of miles, it depends on the total cab fare. Or to find the total cab fare, it depends on how many miles I've gone. Which one makes more sense? It makes more sense to say to find the total cab fare, it depends on how many miles I've gone. So the dependent must be the total cab fare, the independent must be the number of miles. Again, if you do need a shortcut, in science class, you may have learned something called dry mix. This is the y-axis, this is x-axis. In dependent, it responds. And this one you can manipulate or change. So if I need to go 18 miles across town in a cab, what will it cost me? So, I need to write an equation. Y equal, so multiplying $2 times the number of miles, 2x, plus $5 is the initial sitting fee. So another way to find 2x is this. Do you remember rate of change? We've already talked about rate of change. What is it changing here? It is changing plus 2. So in this table, it went from 5 to 7. So it changed $2 in cost for every 1 mile. So it changed $2 in cost for every 1 mile. So that is what is our rate of change. This 2 is our rate of change. So it's $2. It changed $2 for every mile. And do we know how many miles there are? No, that's why I have the x plus our $5 sitting fee. So if I need to go 18 miles across town in a cab, what will it cost me? $2 for every mile I go times 18 miles, that's 36, plus 5 is $41. So let's graph this. In 0 miles, I pay $5. In 1 mile, I pay $7. In 2 miles, I pay $9. 3 miles, I pay $11. In 4 miles, I pay $13. Will I graph this? Connect it or not? Yes, because can a cab go half a mile? Yes, it can. So let's practice. So our number 2 and 3 is more independent. It costs $2 to download the Rockin' Ross Music app. Each song costs 25 cents to download. Create a table, graph, and equation to represent how much money it costs to buy X number of songs. So it costs $2 to download. So let me show you this formula. You will be given this formula, and this is the correct way to write equation. Y equal mx plus b. Y and x are the variables, things we do not know. M represents where the rate of change. B is the initial value. So we're going to be writing it in this form. We always try to put the variable first, and then we try to put the units afterwards. We talked about it in algebraic expressions. So let's look at this. So it costs $2 to download. That is the starting value. That does not change. So you have to pay $2 to download this app. But then what changes is each song costs 25 cents to download. Do we know how many songs we're going to download? Not yet. So what if I download 0 songs? Will I have to pay this 25 cents? No. So $2. What if I download 1 song? 25 cents for 1 song, 25 cents plus $2 is $2.25. What if I download 2 songs? 25 cents for 2 songs, 50 cents plus $2 is $2.50. What if I download 3 songs? 25 cents, 25, 25 is 75 cents plus $2 is $2.75. What if I download 4 songs? 25 cents for 4 songs, $1 plus $2 is $3. And so that is my table. Can I create an equation from this? Well, I know it's going to be y equal. What is our rate of change? What is this changing by? This is changing by 25 cents for every what? 1 song. So 25 cents, the rate of change is 25 cents for every 1 song. Do we know how many songs there are? No. So it's 25 cents x plus what is the starting point, the starting fee? $2 for the download app. So our equation is 25 cents x plus 2. Now let's graph this. Remember to label your axis. So the x is a song value. The y-axis is the cost. Again, which one is the dependent? Which one is the independent? Define the number of songs you have. It depends on the total cost. Or define the total cost. It depends on how many songs there are. That makes more sense. So this must be the dependent. This must be the independent. So 0 song costs $2. 1 song costs $2.25. 2 song costs $2.50. 3 song costs $2.75. 4 song costs $3. And I bet 5 song costs $3.25. Am I going to connect this or not? Is it continuous? No, because you cannot download a fraction of a song. That doesn't make sense. Let's practice another one. Number 3. Stacy starts a saving account with $15. That's how much money she has at that point. Each month, she puts $10 more in her account. Create a table, graph, and equation to represent how much money Stacy will have after X number of months. So she put in $15. That's her initial fee. If 0 months has passed, has she put any money in yet? So no. So she has $15. In a 1 month has passed, so she put in $10 plus the $15 that she deposited. That's $25. In the second month, she put in $10, another $10. That's 10 plus 10, or 10 groups of 2 plus 15 is $35. In the third month, she put in 10, 10, 10, or 10 groups of 3 plus 15 is $45. In the fourth month, she put in 10, 10, 10, 10, 10, or 10 groups of 4 plus 15 is $55. So do we see an equation from this? Can we get an equation out of this? Let's think. How is this changing by? The rate of change is changing by $10 for every month. Do we know how many months have passed? No. So it's 10x plus, what was the initial fee? How much money did you start with? $15. And that is our equation. Let's graph this now. In 0 month, she saved $15. 1 month, she saved $25. 2 months, she saved $35. 3 months, she saved $45. 4 months, she saved $55. Do we see, is this continuous or discrete? Do we connect it or not connect it? No, we're not going to connect it because we're talking about different months, you say. And which one's the dependent and which one's the independent? Let's think. To find the total money, it depends on how many months have passed. That makes more sense. This second part, you may continue watching it or you may not. This is just an extra practice. Mr. Duarte shops at the donut shop every morning to buy a donut and a cup of coffee. He spends 75 cents for this donut and $2.75 for this coffee. Represent the total amount money Mr. Duarte spends for the different amount of days. Write a short verbal description of the mathematics in the story poem. So he buys a donut for 75 cents and a cup of coffee for $2.75 every morning. So how much does he spend every morning? Well, let's add this up and figure out. $3.50 every morning. So use the table below to calculate the dependent from the corresponding. So let's see. 1, 2, 3, 4, 5. What do you think those numbers are? I think these are the number of mornings. And what do you think these numbers are? Why? Well, the cost. Because the cost depends on how many different number of mornings. So the dependent is cost, independent is the number of mornings. God, that's handwriting is so horrible. I'm going to erase that. This should say number of mornings. So in one morning, in the first morning, he spent $3.50. In 2 mornings, $3.50 plus $3.50. What's another way to say $3.50 plus $3.50? What's another shortcut of repeat addition, multiplication? So that'd be $7. In 3 mornings, $3.50 plus $3.50 plus $3.50, or $3.50 times 3 is $10.50. What's $3.50, $3.50, $3.50, $3.50? That's $3.50 times 4. That's $14. And in 5 mornings, that's $3.50 for each morning times 5 mornings. That'd be $17.50. So how much money does Mr. Duarte spend at the donut shop in 1 week? Well, in 1 week, that's 7 days. So if I multiply $3.50 times 7, or I could add it up 7 times. No way. 0. 7 times 5 is 35. Carry to 3. 21 plus 20 is $24.50. He spends $24.50. God, it's expensive. Every week for just a donut and a coffee. Better savings at other places. So define your variables. Write an equation to show the relationship between x and y. So x is the number of mornings. While y is the cost. Because the cost depends on the number of mornings. What's the equation? Well, y equal, let's see, I am multiplying, well, let's look at the rate of change. It is changing $3.50 every 1 morning. So it's changing $3.50 every 1 morning. So it's And do we know how many mornings there are? No. Is there an initial value? Does he have to pay a starting value? No. So y equals 350x. And it's multiplicative, not additive. If we have to graph this, the title I will make it is coffee. The x-axis is labeled as number of mornings. The y-axis is the cost. So in 0 morning, how much would he have spent? $0. In the first morning, he would have spent $3.50. In 2 mornings, I believe it's $7. 3 mornings, 10, 10, 10.50. 3 mornings is 10.50. In 4 mornings, it is $14. 5 mornings, it is $17.50. And are we going to connect it or not? No, because we're talking about the number of mornings for donuts. So it is discrete, not connected. All right, so that is our lesson, our linear relationship. We'll be talking more of this lesson in subsequent lessons.